I will reintroduce myself if there's any new faces in here for this section. I am Richelle Ahlvers with Broadcom. I am the chair of the Scalable Storage Management Technical Work Group that produces the SNIA Swordfish specification. So this session will go into a little more detail on several. Disclaimer, sorry, and I'll tell you what we're going to talk about. Reminder, if you remember nothing else, what is it you're going to remember nothing else but? SNIA.org/swordfish. Got it. All right. Now you can go to sleep again. But it is getting colder in this room. I swear it's getting colder in this room. So we might all have to stand up and do some jumping jacks or something just to... Okay, so what we're going to talk about in this section, we're going to go into a little bit more detail on four things. First one is the class of service concept. So we're going to talk a little bit about how classes of service are constructed, details about lines of service, capabilities, some things about how those three elements work together to build up classes of service. A little bit about schema. I've got a bunch of stuff on schema in here. I'm going to skim over it. I talked about that last year. So there's more detail. Apparently I did like 18 or 19 minutes on it last year. I'm not going to do that this time. I'm just going to talk a little bit more about, some high-level stuff on schema. They're in the slides. You can look at it in more detail. A little bit more on the two configurations we talked about earlier, the ISC and HSC. And also I'm going to actually pull in a little bit of the stuff that Jeff talked about earlier. Inadvertently, I didn't remember that those were actually in his slides, so I'm going to talk about that a little bit more. And then a little bit more on profiles. We inadvertently did a preview of that in the last session, but we're going to talk a little bit more about what and why we're doing with profiles. I'm not going to talk about how they're constructed specifically, but just more about what and why we're doing the profiles. Okay, so just a little recap for anybody that wasn't in here. Not a huge recap of everything we just talked about, but some of the primary swordfish concepts. So swordfish, again, is constructed a little bit differently than previous storage management APIs. One of the primary ways it's different is it's constructed as a service level based structure using class of service. And so a class of service is a choice of utility offered to customers by a service. And those services are storage services. You can see the little hierarchy going down here. So a class of service, and I didn't talk about this last time, but a class of service is defined by selecting from available lines of service. And so there's a hierarchy on how we both define what's available in a system and how you construct classes of service. So we'll get into that in just a couple minutes. So the rest of these things, again, are just normal elements that you've seen before on how we define storage systems. Pools, volumes, groups, file system, file shares. I'm not actually going to talk about that too much. That's just the same slide we saw before. So this is really just a representation of some of the elements in a storage service, right? The storage service is that primary element to manage the logical storage system. That sounds a little confusing if you saw the previous thing where a storage system was something else, but bear with me a minute. So this is how we manage the different storage-related functionality. You can have one or many different storage services in a system. That, whether there's one or many available, is going to be completely implementation dependent. Simpler implementations may just allow you to instrument one storage service. More complex implementations will let you implement multiple storage services. But again, a storage service instance will be where you hang off your pools, your groups, your endpoints, your volumes, or your files, your drives. Anybody who's been in here for a couple of hours will remember Jeff talking about in the Redfish model, where you put drives is flexible. In the Swordfish model, we have drives here, but you can also have those links where to show where in a physical chassis those drives might actually live. So same thing, same concept. Here's where we're using the drives in our model, but you might also have drives showing up in a chassis that says, hey, these drives are in this enclosure over here. And I have no idea why. I apologize for that. My system is. Let me try and reconnect here.
Something's happening.
Let me try a different connector. Sorry about that. There we go. Okay, and so again, storage services. One of the other things down here is class of service, and this is important because all these things are related. Storage group or storage pools and volumes and classes of service are all related. So let's go over and talk about how classes of service, why we have them, how we use them. And then and we'll show a really simple example of how a system might be constructed using class of service and how you might allocate a volume out of one of them. Okay, why class of service? We just talked about we're doing it, but why are we doing it? So modern systems are often built on really complex algorithms. Especially large-scale storage systems, but even virtual, any kind of small virtual systems, SDS configurations, all of them, they're very different, but they're often built. Even rocks have these same capabilities, right? All scaleless systems are built on these things, and vary quite a bit. So one of the things we want to do is abstract a lot of that complexity away from the clients and the users and just say, look, tell me the attributes you want of the system instead of looking at the specifics of why you want, of needing to know the RAID placement or, the data layouts. What is it you actually want to do? That's kind of the why of a lot of this is, class of service helps address this. It really takes it back to what are the attributes of the system you're trying to look at here. So an implementation can then address the set of configuration options that delivers levels of service that are meaningful to the user, right? And so I'll talk about, the capabilities, and how we've classified some of that in a little bit. And these are just the standard classifications. These are all extensible. So I'll make that point as well, right? This is just a starting point. Anybody can add to them. Okay, so these, this is, I'm thinking this is really saying a lot more of the same thing with some examples here too, right? We introduce provisioning based on a requested class of service. A class of service can support one or more desired level of service. It can be completely automated or it can be relatively manual. And so for example, the same level of performance can be delivered using a single drive or via striping multiple drives. And the implementation can hide that. All you're doing as a client is actually, all you have to expose up from a client perspective is say, what performance do I want? And thin provisioning, same thing, right? Vendors have multiple different ways to do that. All you have to do is say, I want thin provisioning. The next thing, kind of the last point here is really that you also, impose on the implementation, it's not just an initial configuration thing. We want to ask the implementations to say, don't just set this up for me and then don't monitor it. We actually want to build in the notion that you need to monitor your compliance to your level of service or your class of service, and then let me know if you aren't compliant anymore. So those are some of the things we built into the system. Okay, and so talking about how these things are constructed. So I've mentioned lines of service. So there's really 5 different ones we built in to the standard, which are data protection, security, and storage, and then I/O connectivity and performance. And each one of those are constrained by the capabilities of the system. So here's how the capabilities are constructed. What you have are basically, at a really high level, data protection. This is how these are kind of replicas for recovery. So you'd specify things in here like replica, the type of replica that's supported by the system, the schedule, and geographic requirements. Security is things like encryption capabilities, authentication, antivirus annotation. Data storage is where you'd specify high availability capabilities, thin provisioning capabilities. Is a system capable of thin provisioning? And recovery time requirements. And so connectivity, you get to things like I/O connectivity. This is where you basically put your storage interface characteristics. So this is the connection type, the media class. So you can see how we've broken out different potential capabilities of the system into these different areas.
I have a specific question about that. I'm sorry to interrupt. Is that where you would specify whether you're using Ethernet as a fabric? Let's say for NVMe over fabrics, you're using Ethernet versus InfiniBand?
Yeah, so that would be a connectivity question. And what you'd actually do there is you'd specify what is the system, sorry, there's a bug here. Specify the connectivity capabilities. And so this is where you get to
speed and latency. Does it get down to that level of detail?
That would be in the performance, and this is where you specify the capabilities. So what you do at a system level, at a storage service level, I got to keep my language precise. But at storage service level, what you would actually do is you start with and saying, here are all what my system is capable of at a high level. So if I have my overall service is capable of supporting, say, I'm an iSCSI device, so I'm capable of supporting iSCSI. That's it. That's all I can say my capabilities are. But if I'm capable of supporting multiple protocols, then I can advertise my capabilities there. But then when I go to construct a specific line of service, the only thing I can do is pick from the capabilities that the overall system has.
I'm sorry, I came in a little late, so hopefully it's not a redundant question. But at what level would you use Swordfish to specify things like RAID 0, RAID 10, RAID 5 capabilities? Because those are not device specific. Those are kind of like, how did I put all these things together? That's not a class of service level.
So the question, just for the recording, is how would you use RAID levels related to class of service? And you actually don't. What you would specify is I want X level of performance or latency, and break those down into what you're trying to accomplish from setting a system up as RAID 1. Why are you using RAID 1? You're using it for availability and performance. So that's where you bring in and you translate it to why are you actually using that level, and mapping it over. So those are, that's, it's a different, it's a little different mindset.
Yeah. So part of the reason for my question is I came from an earlier presentation where a guy from Docker was talking about system capabilities for container storage, and that's the level he's at. And it sounds like there's still a gap between what Docker container persistent storage is looking for and what Swordfish is providing. Is that true? Would you agree with that hypothesis?
George is aching to make a comment here. Go ahead, George.
The underlying reason for going to the line of service type of provisioning, as opposed to specify, I want RAID 1 or I want RAID 15 or whatever, okay, is because modern storage devices often will have multiple RAID levels underneath the skin, and they will manage the use of storage at those different levels to present a volume that has an overall capability in terms of performance or reliability or availability. And to try to get in and specify the details of each segment of storage that is at a different level and what's the policy between, you know, picking this part of the storage or that part of the storage, it's a nightmare. You don't want to go there, right?
But that nightmare is what AWS and Azure and anybody that uses them is facing.
I get it, and we get it. We have added in RAID type, or volume type, we're calling it, as a property, and we'll do that for those people. But I will tell you that they are living in a world that doesn't exist anymore.
So one more point on this and then we'll go ahead. Because these capabilities are here doesn't mean people have to implement them. And when I show the example, I think you'll see this, right? The point of this is that we believe this is the future direction, is to allow systems to let people to move to specifying things by attribute, right? That doesn't mean you actually have to allow someone to move to specifying everything completely automated, but you can. So my example here, I think, will kind of highlight, the flexibility of the system. Okay, so, and here we are to the example. Okay, so what I wanted to do here, this is a really simple example, and it starts to show how you can start to incorporate this into the system. So my example here, I picked the connectivity one because I think it's actually a pretty easy, it's kind of, to me anyway, it was one of the easiest ones to start to internalize how you could bring this into a system. One of the things to note is that a lot of these capabilities or the lines of service and things are actually policies that most systems already have in place. So most, and we've kind of highlighted this, I work for Broadcom. We make RAID on a chip and RAID cards. We have a lot of policies already built into our firmware. And so mapping these two, class of service, lines of service capabilities is not, it's not rocket science. It's how do I take the things that my clients already want me to do, my partners already have, and just say, oh, this just maps to here. I can just turn this already into this, class of service, line of service. Do we have something that maps to every single one of these? No, but I actually have a lot of these already built into my products. So this one is really pretty simple. So one of the points to note here is you can have one or many properties, capabilities, lines of service to define an instrumental class of service. I picked one here, just for an example. So looking at a single capability property. So my example system here basically says, I'm only advertising capabilities around connectivity. So I have I/O connectivity capabilities that says my supported access protocols, which is really just the kind of effectively translates, to the drive type. I support NVMe, SAS, and SATA drives, all different connectivity types. So what I'm going to do here is basically just say, hey, I support all these different connectivity types, and so then I'm going to say, let's create different lines of service that map to the ability to connect different ones of those, and then create different classes of service to differentiate high-speed or low-speed drives out of that, and so that my system will automatically sort that. It's so here's your eye chart for the day for this slide set. I think I actually have some more eye charts coming up in different sections here. So all this does is basically this breaks this down and says here I have this. I have a high capacity and a high performance one, right? All that does is basically over on this one, my line of service goes to the access protocol of SATA, and my access protocol named NVMe over here. And because I've set up those capabilities that had those appropriate names on either side. And I was just able to differentiate and say, okay, system automatically sort SATA drives over here and NVMe drives over here into these classes of service. So now, what that does is, once those classes of service exist, I use that to, when I go to create my storage pools get those attributes of those lines of those classes of service. So when I create my storage pool, I specify I want my storage pool only using this class of service or that class of service. And then I allocate my volumes out of each of those storage pools respectively. So does that make sense, that hierarchy?
So when I create the storage, then that time, what we're going to create the storage class of service?
No, I created the class of service, and then to specify what the constraints are to use. And then I use the class of service as a parameter when I create the storage pool.
So what about like this kind of thing? Okay, I want to use low, high capability storage.
Uh-huh.
But I don't have those kind of storage. Like what happens?
I'm sorry, I didn't get the last half. I want to create the high capability,
Yeah.
right?
But I want to create more from the high capability. But I don't have that.
Well, if you don't have them, and then you say create a storage pool of X amount of capacity, there's two ways to do that. You can just say create a storage pool using all, any available, and then it'll create it as big as you can. And you get basically all the drives that are available. If there's no drives available, you have a storage pool of 0 capacity. Or if you say, give me a storage pool of X amount of capacity, and it doesn't exist, it would fail. But because you basically gave it the constraint of class of service, and class of service had the constraint of only use this kind of drive, effectively. So, and then when I actually go, so we basically, it's effectively a policy that got applied in there, inside that. So then when we go to create the volume, all you have to do with the volume is say, or the other way to do that would be to, create a volume. When you go to create a volume, there's two ways to do that. One is say, I want to explicitly create it out of that pool that I created. The other way to do it is this way, which is to say, find me a storage pool that matches this class of service, and that can do it out of this capacity, that has this amount of available capacity, and it searches and finds it. So you have multiple options. You could, if you know explicitly the pool you want to use, or you can just say, give it the parameter of, I want a high performance that's got this amount of capacity, and it will go find you the appropriate pool and create it.
Would that look the same way if you added the source pool instead? Would it be a link or would it be a capacity source?
It depends on the structure. I'd have to go back and look specifically at the volume structure to see whether. I think in volume, I think it would be you just.
After creation, you have a capacity source which would meet the requirements there.
Yeah.
A general question, I apologize, I came in late. Would Swordfish be something that is targeting public cloud, or is it more for private data centers and how private data centers set up storage?
All of the above. Okay. So I have 3 more topics in this presentation, and so let me just jump on ahead. Schema, like I already said, I'm going to skip a bunch of the slides. You guys can reference them. I'm just going to talk about the first couple 3 here and not jump into the example. The slides are all posted. You can go reference them. Jeff talked a little bit about schema earlier. I'm going to talk, just go a little bit about some of the attributes of schema. And if you want, we can talk anytime offline if you have questions about specifics of schema, if you're digging into schema and want to use them. There are 2 types of schema. The CSDL is where we do all of the schema creation. And Jeff's already talked about, we're kind of moving away a little bit from the OData stuff and starting to add the open API support. CSDL, everything's all in one file. The JSON file are all created from tools from CSDL. I will always go look at the CSDL ones because that's where we do all the work. So if you have questions, I will look at the CSDL ones. They're functionally equivalent. Everything should be in. Not everything is actually in both files because of the way some differences between the schema languages, but they are functionally equivalent. The file rules, just a few file rules to note. Each resource is typically in its own file. There are a few places where when you're looking for things, you will find multiple entities defined in the same file, where we have supporting structures defined, complex types, enums, some other things like that. You will find them all in, tagged along with a supporting structure. So you would see them in, like, with their find them with the namespace associated to them. That's how you reference them. So there's a lot of shared structures and enums and things that you will reference by the namespace of the primary file and entity that they're associated with. There's a lot of annotations, both Redfish and OData, that define and constrain. If I were going through the full explanation, this would make more sense because I'd be showing you a bunch of examples with them. But the annotations are kind of split between Redfish annotations and OData annotations, but most everything in there is either a primary, it's a type, it's a property, or it's an annotation that constrains everything. And so if you're looking for in a schema on how to do something, it's probably an annotation that's defining or constraining something. There are a small set of OData properties that also go in there, like at OData properties. but it's a relatively small set. So other kind of area to talk about related to schema is using the schema files. In general, clients don't actually have to use the schema files, but you know, we've talked about that. This is REST, but there's kind of two different ways that, you know, obviously implementers are going to use them quite heavily, but clients can parse them as they're interacting. They can parse them dynamically, or purpose-built clients may never actually read them. Developers will read them. All the schema, and Jeff made this point earlier, but I kind of like to reiterate it because we don't actually have any OEMs posting their, you know, that have even, anyone besides SNIA, I should say. No one besides SNIA has republished their schema on the DMTF website, so I'm highlighting this because we'd like to encourage people to look at publishing their schema on the OEM website, or on the DMTF website. We have set this up, and SNIA has flushed out all the bugs with it, but we have a site set up out there specifically to allow people to repost their schema. And so we'd strongly, strongly, strongly encourage anyone who is developing schema to republish their schema on the DMTF website. It's just going to be far more efficient to point people all to one spot, even if you have them on your own company website somewhere, because we all know those tend to be a little not necessarily always under our control, but one other point, you know, clients and services may also have local copies. Those also need to be very strongly versioned. So even the OEM versions need to be very, very tightly versioned. If the clients and services are going to have local copies, this is for just for pure efficiency reasons, because a lot of times you don't have the ability to get to the external website to download a copy of the schema. In the RDE configuration that Jeff was talking about this morning, this is entirely because configurations don't have access to get full schema, so we have the dictionaries instead. So that's about all I think I'm going to say about this. Unless anybody has any questions on schema, I think I'm going to pop right ahead of all of the examples. And if anybody has any questions, we can come back to that later. So for the deploying Swordfish, I wanted to talk about in a little bit more detail about these two configurations. We talked about this just real briefly when I talked about the fact that there were two different configurations. There's really kind of two different things I wanted to talk about here. One about is the reason for and when you might use these two different configurations. So there's this kind of progression in direct attach, and Jeff started this a little bit when he was talking about Redfish storage. So Redfish storage, and this is weirdly a duplication of what he said, kind of starts with this notion of, you know, a server with direct connect drives, and this is where you use simple storage, right? I have a drive connected, you know, on a bus, you know, and there's nothing else needed there, right? Or the next one is you get to, I have a server with an HBA with connected drives, or a RAID card with a very small number of drives. All I have is storage plus volumes plus drives. So you're starting to go, okay, when do I add Swordfish? Well, this is where you add Swordfish, right? I want to move up to, I want to increase the scale, either the number of the drives or the functionality. We start to get into any of the stuff we just saw. Maybe it's just storage pools. Maybe it's, I want to start adding that automation. That's the silly example I just showed of automatically sorting, you know, by connectivity type and have the system do that for me. and add a class of service that sorts that out automatically for me. Maybe it's more functionality, so that's the functionality, but that's where I start adding a storage service in, right? It can be any of those dimensions or more. So I plug that into the storage controller because I've got a need to get past just a volume and a drive. I want to add any of those collections that we've listed off that come with Swordfish, right? It doesn't have to be a really complex class of service configuration. It can be a simple one. It can be, I've got pools. I want to use pools as a management construct because I got above 4 drives and I want to be able to group them. So that's where you start adding Swordfish in. And then the standalone configurations we talked about a little bit earlier. This is again far more obvious. I've got external storage. I've got SDS configurations. The other one that we get to, and I had a question about this between sessions, layered or composed systems. Maybe I have a NAS box or a file system that's actually built off of a server that's using a RAID card in it. So I've got an ISC configuration, but I've got a file system that's sitting on top of it. So the file system is actually an HSC configuration, but the block that's using it is an ISC configuration. So, or the block could even be, for that matter, simple. But you start to see these layered configurations, or you could have, so it could be, a Redfish with Swordfish on top of it. You could have, a BMC serving one configuration and a Swordfish on another layer. So you could have a lot of different permutations on how your system's built. Layered, composed, a lot of different configurations and options here. Does that make sense?
Question. How would you manage a cluster of, let's say, standalone servers with attached drives? Would I get an integrated view of the entire cluster using Swordfish, or do I need to look at each node as an independent ISC configuration?
You could do either one. It kind of depends on on how you want to present it.
So Swordfish has a capability to say, I want to view my entire cluster as one single system, and which would have a node-wise hierarchy to say, I have a node followed by a storage controller and a set of drives or volumes or file system on top of it. And then manage the whole thing.
It depends on how you're constructing your system, right? If each one of those things is really independent, and you don't have any functionality you're trying to aggregate across it, it just depends on how you're constructing your system. If you're trying to present it all as a single system, you could make one Swordfish one storage service that brings them all together. But you'd have to basically draw out your system and say, where's the functionality that aggregates it? Yes, George.
I just want to throw it, just keep in mind that the computer system concept, the storage system, doesn't have to be physical storage systems. You can create a storage system that represents the logical aggregation of multiple systems.
Okay, so, yeah, I put all these pictures in here, and then for some reason, it's just the same pictures I had before. So, and I think I pretty much just said everything in the same. So if you want to look at the pictures, because pictures are always nice. But these are just the configurations I was just talking to, right? So these can be hierarchical, they can be peer-to-peer, any other questions on these configurations? Okay. All right. Yes.
So it seems like when you're describing this, these are you have to decide what class of service you want when you're going to define this through Swordfish. So you have to know whether you're going to have a bulk or a high performance. Is that correct? Or is there some way, like if I have a cold line that then gets hot, I need to change the class of service? Can Swordfish handle that? Yep.
Yeah,
Yeah, you would update the class of service. So a volume has a class of service. If you change the class of service, if the system allows you to change it, then you would expect the system to migrate the volume to the hot storage.
So it'll migrate, that's what's going on behind the scenes, is the Swordfish, or the
Yeah, it's-
behind it should do that migration for you.
Exactly. And
yeah.
that's sort of the level of simplification from the client point of view that we're trying to drive through Swordfish.
yeah,
Obviously, there's a lot of complexity underneath
Yeah.
the skin.
And
So you
it's,
don't have to define a fast one and then migrate it. The system should do it behind the scenes.
it's, again, it's if the implementation is capable of it.
Yes. Of course.
Yeah. And the other thing was the example I used just had one specific line of service, and you can have multiple lines of service and capabilities all defined for a volume or for a pool, and then they all have to work in concert.
Okay.
So, and if you want to see examples of that, you can go look at our mock-ups, which have, multiples defined in different permutations, so.
One caveat there. In the class of service, right now we have the 5 types of lines of service, okay? You'll typically have only one of each of those. Exception is the data protection line of service. I might have claps or snaps and remote volumes and something else. Those can all be combined.
All right, we only have 10 minutes left, so let me talk a little bit about features. This is the last section, and then we should just have a couple minutes left for questions, any additional questions. This is a little bit about, again, why we're doing features. We talked about this a little bit at the end of the last section. So we've talked about profiles. We've really split this notion up, and this is still work in progress. We don't have this fully defined yet, but we're hoping to have a work in progress definition of this out, still at the end of this year. But this is focused on, the interactions of how do clients determine which implementations they can support. So we've split this up into 2 pieces called features and profiles. So the profiles are the really detailed descriptions, and the features are what we advertise. So at runtime, clients can look for what we call advertised implemented features, right? So this is a feature that this implementation is actually supporting. And development, you can look at the detailed profiles that says, what does that mean? So, and a really simple example is, I support, discovery. And discovery means that when you look at the profile, that means I support get on all of these objects. And so, that's straightforward, but, that's, it's a really useful information to say, okay, that's all, that I can count on when you advertise discovery that I can do a get on stored service. So these are, features are used for determining, functionality for required configurations. We've been working with several of our participating clients representing, general purpose management apps, very specific storage management, OS management, to say what features and how do we categorize those. To keep that list small. We don't want this to be, a list of 100 different permutations. We want this list to be, under 10 if we can. So we have, a small list of what the features are, and then the profiles get to be much more detailed to say, how do we do that? And then also the features map to, or the profiles map to different kinds of configurations so that we have the flexibility there. We also use them to help develop certification and conformance and testing requirements for different permutations. Okay, so advertised features end up looking like similar things for standard features and advanced features. So we would expect all products to support the standard features. We also have for different service types, so you'll be able to say, I support block events for block, provisioning for block, to be able to differentiate, because those will actually map to different profiles. Provisioning for file is going to have different functionality than provisioning for what did I say? Block would be different than for file. And then advanced features, these would be things that not every device class out there would support. So, local and remote replication are great examples, right? Little tiny devices don't support.
Is there any vendor-specific category that you have put in, or everybody has to just adhere to this one?
This is not vendor-specific at this point, and
This is
client.
generic, right? So
Yeah,
is there a section which says vendor-specific features that I may want to implement?
Right now, the clients have been very clear that they don't want this level to have vendor-specific functionality in it. We could have to talk offline, because I only have a couple minutes here, about what types of things you would be looking at from a vendor-specific. What you'd be thinking there. Okay, so profiles. This should be, I think I've already said most of this already. Profiles are very detailed descriptions, right? It's for, this is where what properties need to be instrumented in what configurations. So these are going to be used far more in the development cycle and in testing to say, what specifically do I need to implement? The example I gave before for discovery is actually a really straightforward one. You get into like remote replication, and it's going to be a very detailed permutation of, I need to support this property and this property and this property, and if I support this, I need to support these things and these things and these things and these things. So it gets far more convoluted, and that does not need to be advertised or exposed up at runtime. That needs to be something that an implementer needs to know the details of. So kind of getting back to some of the questions earlier about, how do you know specifically what to implement? This is how you know specifically what to implement for a particular configuration. For a specific feature, right? If I'm going to advertise that I support remote replication, I need to, so performance metrics, right? If I'm going to support performance metrics, I need to support the IO statistics module, every property on volume, on storage pool, on these objects. I have to support not just this object, but every single property in it. And so that's the level of specificity that goes into a profile. And also the kind of the level of granularity. Let's see, so I think, okay, these are also in here. I went over these in the last section a little bit. Just a quick, I'm going to skip all of those, because if you haven't already seen them again, you can go back and get them. All the resources that are available. Everything's available. Pointers on SNIA.org/swordfish. But the two more things to remember are, we have the BOF tonight, so come and ask questions. Everything from who's adopting to who's working on integration. There's some really cool stuff going on in our ecosystem about, and some folks working on some scale out, some tools. Don will talk more about those in his section. But we also have some folks working on some layered integration in the OpenSDS space. and talking about working with some folks from OCP and ODCC. We can talk more about that tonight. And then visit the hands-on workshop tomorrow and see, you know, kind of the state of the ecosystem, some implementations and other things. All right, thank you, everybody.